Hello, everyone. Welcome to Advent of Code, day one. This is Will, getting ready to have some fun with this. So I have my Advent of Code page open here. I've been with some of the problems from last year. I have my REPL environment set up. Going to be doing this in Clojure, if at all possible. Looks like we have about 50 seconds before the problem goes live. You can see I wrote a little couple helper functions here to make use of my clipboard and just get a little bit faster. Faster solutions here. Yeah, real excited about the challenge, and hopefully we'll get a right answer pretty quick. And if not, well, it's all for fun anyway. All right, about 10 seconds. All right. That was exciting and a lot more difficult than the Advent of Code problem number 1 from last year. So let's go over it. So let's see, back to day 1. All right. So this problem is a state machine problem. You basically have a state given by your position and your bearing, and then you receive a list of inputs like these telling you how you're going to change your bearing and then how many steps forward to take. So what approach should I use? Here we go. All right, so first of all, here we have a rotation function. This takes one of these characters here, either L or R, and a direction, so that this is one you're bearing here, and modifies it. So I use keywords to represent the bearings. You could, how else could you do this? I guess you could use arithmetic in order to get the sort of wraparound behavior. So you could represent basically all of your the directions that you could be in as, like, say the numbers went to 0 through 3, and then anytime if you were making a left change, then that would just be like an increment, and then make sure that you take a remainder, and right would be like a decrement there. And then there's your actual move operation. So here is here I'm representing the state as a vector with 3 elements. This is bearing, x location, y location. Pulling out the first part of the instruction here, which is going to be this L or R, and also parsing an integer that is composed of the rest of the instruction. So my first roadblock in fixing this problem is that I had incorrectly assumed that the number of steps forward was always going to be a single number, and so my implementation instead of being like this was like this. So I was using a second instead of the rest. So that was a bug. So then after you parse the number of steps, you basically say, okay, my new bearing is going to be given by this, and I could like use a let to not have so much duplication of code here. And then you say, given where it is that I'm facing now, how is my location going to change? And so here is my new bearing. Here's my new x coordinate. You can see that if I was going north or south, the x coordinate doesn't change. And if I'm going east or west, I'm adding or subtracting from the x coordinate, depending on which one I need. And then same here for changing the y coordinate. And then those steps together were enough to get the right answer for the first part of the problem, which I seem to have lost somewhere. But we could probably re-implement it pretty easily. We just do a reduce, starting with using this move function, starting going north, although the direction doesn't matter, and operating over my clipboard lines, giving a final location. So finally, we're pointing south, and we're 122 to the west, I guess, and 132, or actually, how are we doing this? Looks like west was positive in my map system. Anyway, it doesn't matter for the purposes of the answer. You just add the absolute value of these two numbers together, and you get 152, which is the first answer. All right. For the second part of the problem, let's see. Right. So find the first block that you go to twice. So if the first part of the problem is solvable with reduce, then the second part of the problem is solved with a reductions. So what a reductions is it takes just like reduce, it takes a state transformation function and a starting state, and then a like sequence of commands. But what reductions gives you, instead of a final answer, it gives you every intermediate answer along the way. So to give you an idea of what that looks like, just copy some information here to my clipboard. So if we were taking, let's just say, the first 10 commands here, then that looks something like this. So start out facing north at position 0, 0, read in one command, which is turn left. And so we're going west 3 steps, then we go north 1 step, and then looks like we're going west again, and then we go south. Okay, so so what we can do with this is we can map a rest to it, and then that gives us basically the list of all of our locations after following each of these instructions. Then we can break them up. Oh, right. So this by itself was what I started with, and I basically said, okay, here's a list of all of our locations. What is the first one of these that's duplicated? And the program came back and said, well, those locations are never duplicated. And I looked at it, stared at it, couldn't figure out what was going wrong until I looked at the example that they provided here. And they said, first location is 4 blocks away due east. And what that means is that it's not enough just to get the single location that you get before each instruction. You also have to compute each of the instructions that each of the steps along the way in between the instructions. So if you're going here like to the west 3 steps, then you need a list of all of those steps, and then find the first match. So what I did was I wrote this function blocks here, which initially had some trouble, but so the point of blocks is that it takes 2 coordinates and then gives you a list of all of the coordinates that occur in between those blocks. So the blocks from 0 to 0 and 0 to 10. Why doesn't it like that? Oh, because I have to. Blocks from 0 to 0 to 0 to 10 take you from 0, 0, 0, 1, 0, 2, and so forth. I had to write this range helper function here because just because of the way Clojure's range function works, you can't give it range from 10 to negative 10. This will just give you an empty list. So if you are going down, then I had to do this little thing here where I'm reversing the range. Yeah. So after debugging this blocks function, then what we can do is we can take all of our individual positions along the way, and then compute the partition to one of them. So this is sort of easier to show. Basically saying, all right, I'm starting at 0, 0, then I'm going to 3, 0. Then I'm starting at 3, 0, and then going to 3, negative 1. Then I'm starting at 3, negative 1, and then going to 7, negative 1. And then for each of these pairs, what we're doing is we're applying this blocks function to it. And because of an off by 1 situation, we also have to take the rest of this, which you can kind of see if you didn't take this rest here, then you would say, for example, take like 3, 0 twice. What this looks like as an intermediate step is there's buffer. For the first 10 steps, you can see now each of these locations is only changing by 1 block at a time, which is what we want. And then I just wrote up a really quick first match function here. I don't know if there is I don't know if there's a more idiomatic way to do this than to write my own loop. My first approach was to basically do it in 2 passes to get a frequency map of all the locations and find all the locations that had a frequency of more than 1, and then sort of use that as a filter over all of the blocks that have been seen. That's not really any better, I would say, because it requires you to run over the entire collection twice. But this code right here, first match. This is a lot of code for not doing a whole lot of work. All right, well, that was a lot of fun. That was more challenging than I expected for a day 1 problem, but I did get a couple of points. Let's see if I'm on the leaderboard. I am. Looks like I'm tied for 62nd place. Well, that was a lot of fun. Like I said, I'm looking forward to future nights. And if you're watching this with me, thanks for watching, and hope you'll join me tomorrow. Thanks. Oh, hello.